Alright, so we are now in chapter 4. So chapter 4 is about the simple structure. So in this chapter, I'm going to give you a few examples of the simple structure, such as sodium chloride, cesium chloride, and so on, that diamond. So before demonstrating the structure, the simple structure, so you may question, how do we know the structure? Because the structure is very small, right? With what technique that we can know what is the structure of the solid? So the answer is here, by X-ray diffraction. Okay, so this X-ray diffraction I will discuss in detail in next chapter, chapter 5. But at this moment, I just tell you that you just need the X-ray and then the camera recorder. So we shoot the X-ray to the compound or to the solid or to the single crystal material. Then the X-ray will interact with the electron inside the crystalline solid. Then it will produce the diffraction. Okay, from this diffraction pattern, we process it through like photosynthesis, and then we will obtain the structure like this. Okay, so in this chapter, I will introduce you a few different types of the simple structure. And then in next chapter, I will introduce you the technique to determine the structure, which is the X-ray crystallography. Okay, so in this chapter 4, I will give you some example of simple crystal structure, such as the copper, aluminum, lead, nickel, which have the FCC crystal structure. FCC stands for face center cubic. Okay, for FCC crystal structure, each atom has 12 nearest neighbor. Okay, and then for sodium chloride structure, the sodium chloride structure, the underlying Bravais lattice is face center cubic, and each atom has 6 atoms of the opposite kind as nearest neighbor. The shape of the primitive cell is rhombohedron. Other example that having the same a similar structure like the sodium chloride is like lithium hydride, sodium, potassium chloride, potassium bromide, and magnesium oxide, MgO. Okay. Just now I told you that for copper, aluminum, lead, and nickel, they have 12 nearest neighbor. How do we calculate the 12 nearest neighbor? Okay, let's say if I take, okay, this is a face center cubic, right? Face center cubic. Can I see that? The yellow atom is actually on this plane, face center. So the green one, you see the green one? The green one is actually on this plane. Okay, the green one on this plane. The yellow one on this plane. You see that? It's very complicated, but I think if you look at it carefully, then you can see lah. The red one. See that the red one is on this plane. The red one is on this plane. So this is a face center cubic. Okay. So face center cubic, if we pick one of the atom or lattice point, let's say I pick this and this at lattice point. You can pick any lattice point. This is a corner one, corner at lattice point, corner lattice point, and this is a face lattice point. Okay, the lattice point that located on the plane. So how do we calculate the 12 nearest neighbor? Okay, the first 4 nearest neighbor will be 1, 2, 3, 4. They all have the same distance. Okay, so half A, half A. Okay, all have a nearest neighbor, all have the same nearest distance, not neighbor, nearest distance. So now we have 4 plus the other 4, okay? Half A, right? Then get the hypotenuse. So another 4. Then this is the last 4, okay? So half A. Here to here is A. So here to here is half A. Here to here is A. Then here to here is half A. Right? So they all have the same nearest distance, right? So you have 12 nearest neighbor. Okay, now if we know that there are 2 types of the atom or 2 types of lattice point in the face center cubic. So just now I picked the lattice point that on the plane, but then now I pick the lattice point that on the corner. By the definition of Bravais lattice, the lattice point on the plane should have exactly same environment with the lattice point of the corner, right? Remember that the Bravais lattice, you have two requirements. One is that all the basics should be the same. Second, all the lattice points should have the same environment. So now we examine whether the corner lattice point also have 12 nearest neighbor. So now I will show you one by one. So this is a corner atom or corner lattice point. So the first 4 nearest neighbor will be this one: half A, half A, half A, half A, half A, half A, and then hypotenuse, right? Hypotenuse. So this is 4 plus the next 4, 1, 2, and then the bottom they got another 1, 4. Then the last 4, you have also another 4. So the total will be 12 also. Therefore, this BCC is a Bravais lattice, and then no matter for the face atom lattice point or the corner lattice or the corner lattice point or the corner atom, they both have the same environment and they both have 12 nearest neighbor with the same nearest neighbor distance. Okay. So this slide has actually explained this statement. So for FCC crystal structure, so each atom, no matter at the plane or no matter at the corner or on the plane, they all have 12 nearest neighbors with the same distance. Okay. So now the next structure that I introduced you just now was the NaCl. So NaCl, we know that this is garam, sorry, right? Short. So how the garam look like? The garam look like this, okay? It composed of Na and Cl, and then the unit cell length is A equal to 5.63 angstrom. This is one unit cell.